Hey everybody, I'm Austin with PDQ.com. We're going to continue on with our networking videos here. We've got a part 2 for you. So to go into what we're going to talk about today just a little bit, we're going to touch on segmentation and interface properties. Now it says part 1 because next time we've got a little bit more within that realm. But today we're going to talk about specifically VLANs and trunking and how you can accomplish that in your network. So let's go ahead and get started. Okay, so last time, in the last video, we talked about broadcast domains, right? Broadcast domain is, to summarize, is basically how far a broadcast will go if a client were to send it, if that makes sense. So what we're going to do, or what VLANs are in terms of broadcast domains, is that they segment them, right? So if you have one computer in VLAN 2 and one computer in VLAN 3, if that computer in VLAN 2 were to send a broadcast on that network, it would not be received by the computer on VLAN 3. That's basically the gist of a VLAN. So it reduces broadcast, like it says here, less noisy traffic, you could say. You don't want large VLANs. I would say avoid anything larger than a /24 on one VLAN. And it allows for segmentation. You could call it security, but basically what we mean, or what is stated by VLANs allowing for security, is that you can apply what are called access control lists to VLANs. It also reduces the scope of a spanning tree loop, which we'll go into next video. But I want to remind you that VLANs are not inherently secure. If two devices are in separate VLANs, that doesn't necessarily mean that there is any inherent security by that logical separation between the two devices. So we're going to go ahead and jump into a lab real quick. I'm just going to show you how to apply a VLAN to a switch port and what that looks like on Cisco. So let's go ahead and get started. Okay. So what you see here are two switches on the right. I've disconnected switch 1 and switch 3 over there just to keep this simple. So let's say that you've been told on switch 2 to apply PC1 to VLAN 3, right? So let's go ahead and kind of walk through what that would look like. And just a reminder, this is what it would look like within Cisco. There are multiple vendors for networking solutions. I'm sure that they have plenty of documentation for how to do this. It is all pretty similar. So we're going to go ahead and enable real quick. And then we're going to go into what's called the configuration terminal. We won't go too deep into what the Cisco commands are specifically for what enable means, what configuration terminal means, but basically this allows us to actually create a VLAN. So I believe I said VLAN 3, so we're going to go ahead and just say VLAN 3 within configuration terminal. So this now drops us into a sub configuration for that VLAN, and we're going to go ahead and name it PDQ because that's where we're at. Uh-oh. We have an identical name. So two VLANs within Cisco cannot have the same VLAN. VLAN name or VLAN ID, right? So we'll go ahead and just name this PDQ2. Just like that. And then in Cisco, the VLAN will not be created and the configurations will not be applied until you've exited the VLAN configuration. So all we have to do is press exit and the VLAN has been created. Easy enough. We can verify that with do show VLAN brief. There you go. We see PDQ, VLAN 500, and PDQ2, VLAN 3, and then the default VLAN, VLAN 1. Like I said, some vendors do the default VLAN a little differently, but if you know Cisco, default VLAN is definitely 1. So let's go ahead and look at PC1's port. I'm just verifying that it's gigabit 11 here. So let's do a do show run interface G11. Sweet. So nothing's really happening here. The reason we're not seeing any VLANs applied is because there is a default configuration happening here. There are a bunch of hidden configurations in this interface. You can verify that with do show run all. And then honestly, you have to section it out. So I like to do section, we're going to just say 1.1. Now we might get a lot more here than we anticipate, but I'm basically showing you what the default configuration looks like on an interface. And I'll go ahead and try to highlight that when it pops up. We'll go ahead and give this switch just a second. Sweet. Maybe I broke it. I'm kind of asking a lot, I suppose. There we go. Yeah, we got a lot of stuff here. Okay. So the default configurations have loaded. You can see that it starts here with interface gigabit Ethernet 1/1, and then all of those sub commands underneath that interface, those are default, right? So when you're looking at a running configuration and you only see these many configurations, that there's so much underneath that's not happening. So you have to be careful what is by default, right? But we're gonna go ahead and just throw this into VLAN 3. So you want to go into the interface subcommand and then switch port access VLAN 3. Dang, that was that easy, huh? We're gonna say switch port mode access as well. And we're gonna go ahead and type end. Okay, it's that simple. If you wanna throw something in a VLAN within Cisco, it's this easy, right? So we're gonna go ahead and try to generate some traffic on this bad boy, and I believe it's just DHCP. So what's happening right now is this is basically trying to emulate DHCP, right? Those Ds are the first letter in the DORA, so it's trying to discover a DHCP server, but we don't have one, obviously. But what we're gonna know is that if we go ahead and do show MAC address table, we're gonna say VLAN 3. We don't have anything. That's kind of weird. All right, hold on one sec. Okay, so the reason we weren't seeing anything is that, like we're going to talk about in the next episode, spanning tree was in its states or trying to figure out if there are any BPDUs coming in. So when we sent that DHCP discover packet or those packets, nothing was actually received by the switch because it was in a block state or a learning state trying to find if there's a BPDU on this interface. Because we didn't enable what's called port fast, you're not going to immediately be able to send packets as soon as you connect that client to that VLAN. So now that we can see this MAC address, if we look at this output right here, we see that the MAC address is in VLAN 3 and it's off of port G11. That's exactly what we wanted. We fulfilled the request to apply this PC to this VLAN. So now we've got a little bit of another issue here, or maybe not even an issue, but we've got a little topic that we can talk about. So let's say that if you reference back to that diagram, you've had the two switches and we had two clients hanging off of that. What if PC1 at the top wanted to contact PC2 at the bottom? How would you get VLAN 3 across that interconnection between switch 1 and switch 2? The answer is right here. It's 802.1q trunking, right? So what happens is inside the Ethernet header, there's some space, or the switch creates some space for a VLAN tag. What it basically does is, like it shows here, it just inserts a little VLAN tag and then identifies the VLAN ID. And there's a few more options that are triggered depending on what needs to happen. Like we talked about in the last episode, within even just an Ethernet header, within the options within the header, there are so many things that are triggered that it can get kind of hard to keep up with what's happening. But basically for the VLAN tag, the only thing we care about is the VLAN ID. So within that VLAN ID on the far right, within this VLAN data frame, that's where that VLAN 3 would be stapled, going from one switch to another, and then it would be ripped out as it leaves to the client on the far side. The client would not see that VLAN ID. The only way you would see that is if you're monitoring traffic between the two switches, which we can go ahead and try to do. So, like I said, it adds a tag inside of a regular Ethernet frame. We discussed last time that the maximum size of a PDU can only be 15, 18 bytes, right? Well, they kind of break the rules a little, or it's an IEEE standard. It is a rule, but the switches actually increased the maximum PDU size to 1522 to account for this addition to the Ethernet header, right? And then we can touch on native VLANs real quick too. So let's say that you apply a trunk to a host interface that isn't enabled for trunking, right? So when that host sends a packet, it's not going to be tagged. So the switch will throw that packet into what's called a native VLAN. Basically, it's a setting for untagged traffic. If an interface that is supposed to be a trunk is configured with let's say a native VLAN of 5, and the host sends a DHCP packet that isn't tagged, then it will default to VLAN 5, and the switch will process that as if it's in VLAN 5, if I'm making any sense. So like I say here, it defaults to VLAN 1 within Cisco products. VLAN 1 in Cisco is default pretty much for everything. So let's go ahead and try to lab this real quick. Going back to my previous little lab here. So we've got switch 2 and switch 4. So what I'm going to do is use CDP, Cisco Discovery Protocol, to see what interfaces connect to our switch on the other side. So we see the device ID, the default is switch. That's why our host name is switch, and we're also seeing switch on the other side. But we can see that from our perspective, gigabit 03 and 02 are attached. So we're going to go ahead and do a show run interface G02. All right, we've got nothing going on here. Perfect. So we're going to say configuration terminal, interface G02, switch port mode, trunk. Oh, perfect. This is a good explanation. So long time ago, Cisco had another trunking protocol. I believe it was called ISL. I'm not even going to touch on it. You should know it exists. You should know that it's inferior to .1Q, and you probably won't ever see it. For some reason, they still have it in their virtual switches, probably because they want instructors like myself to get caught up in explaining what ISL is when it really isn't important anymore. So we're going to say switch port, trunk, encapsulation, and I can guarantee that it's going to have .1Q and ISL right there, right? You can have it negotiate if you want to, but I like full control over my network. I like it to be very predictable. So I'm going to say switch port trunk encapsulation .1Q. I'm going to say switch port mode trunk. I'm going to say switch port trunk allowed VLAN 3. Let's go ahead and say switch port trunk native VLAN 500. Sweet. So if you remember, VLAN 500 was an older PDQ subnet that we have. And I'm sure you're seeing errors here for a native VLAN mismatch discovered. You want your native VLANs to be the same on both sides. It's unwise. It makes it more predictable when your native VLAN matches across your entire domain. It doesn't necessarily break things. It's just not recommended, and that's why CDP gives you that information right here. So we'll probably get this output a few more times until I can change it on the far side. So let's go ahead and say show interface trunk. Okay, so we know that G02 is configured as a trunk on this switch port. VLANs allowed on the trunk are 3. VLANs allowed and active in the management domain, 3. And then VLANs in spanning tree forwarding state, 3. Again, we'll go into spanning tree next time for sure. But just remember this when we get there. And then you can see on the far right at the top, it says native VLAN 500. So any untagged frames will be put into VLAN 500 and processed as such. Sweet. All right, let's go down to switch 4 and enable config T. Let's go ahead and create the VLAN. VLAN 3, name PDQ 2. We're going to exit, so it's actually applied. We're going to do the same thing here. The reason I prefix a lot of my commands with do within the configuration terminal is because if I were just to type show run, that's not a command that can be run within the configuration terminal. Do allows us to run what I would call show commands in this area. So we're going to say do show CDP neighbor to see who our neighbors are. We see switch, which is the other side, the other guy we just configured. We remember that we configured G02. I can see that my local interface that connects to G02 is G02. So perfect. We're going to go ahead and get into that interface commandlet real quick. We're going to say switch port mode trunk, and it's going to hit us with the encapsulation error. So we're going to say switch port trunk encapsulation .1Q. And then we're going to up arrow because we're a sysad and we hit up arrow instead of typing a bunch of times. So switch port mode trunk, we're going to say switch port trunk allowed VLAN 3, and then switch port trunk native VLAN 500. Sweet. So I'm going to say, we're going to verify that the VLAN exists, which maybe we should have done before this, but that's okay. Show VLAN brief. We see a few VLANs here. This is a lab, so you're going to see a few VLANs, but the ones that matter are VLAN 500, PDQ, and VLAN 3, PDQ 2. Easy. And then we're going to say show interface trunk. Perfect. Looks identical to the other side, which is exactly what we would expect. And we should stop receiving those CDP native VLAN errors because we set the native VLAN to the same on both sides, and CDP will stop shooting us that error. So, all right, perfect. How do we validate this works? It's kind of hard unless you have some IP addresses configured on these clients and some connectivity. But what we can do is within GNS3, we can start a packet capture on an interface and see what that looks like. So one moment while this boots. All right, so we've got DHCP, or excuse me. So now we've got Wireshark set up on our interface that faces the client just south of the one we were working on, if that makes any sense, off switch 4. So we're gonna try to shoot a DHCP packet from the host on the top, or host 1 to host 2, and we're gonna see if we can identify anything. Let's go ahead and do that. We're not seeing anything. Interesting. I wonder why. Let's go ahead and show MAC address VLAN 3. Okay, so we're seeing the client, the PC1 MAC address coming in from switch 2, or the top switch in our diagram here, but we're not seeing another MAC address. That's crazy. Oh, silly me. It's almost like I planned for this. Let's go ahead and just throw that host into that whole PC2 into VLAN 3, and then we'll be good. So if this seems like a lot of the same commands over and over again, that's because that's exactly what networking is like. You take one command and you apply it about 1,000 times. So super fun, super fun. So let's see what interface we're hanging off of. Let's see what GNS3 can tell us. GI12. So we're going to say gigabit 12 switch port mode access, which it is by default. I'm just reiterating it here. Switch port access VLAN 3. Sweet. Now, in order to get a MAC address in the MAC address table, the switch has to receive a frame that it can actually apply the source MAC address to its MAC address table. A lot of MAC said right there, I know. All right, so let's generate some packets. Let's go ahead and look at a couple things. A little tidbit. At the end there, within the show, outside of configuration terminal, if you type a command and you don't have a domain lookup disabled, you're gonna get this issue right here where it tries to translate your command to a domain server. Yeah, fun stuff. Thank you, Cisco. We're gonna try to control shift 6X, see if we can get that to stop. Perfect. So let's do this. Show MAC VLAN 3. We don't see anything. I'm sure that is caused by a spanning tree. Let's go ahead and try that one more time. Boom, there we go. So I'm gonna shoot some DHCP packets from PC1 to PC2. Again, remember, the reason I'm using DHCP is DHCP is a broadcast domain protocol. When DHCP is initialized, it's only contained within the VLAN, and it is seen by all packets or all computers within the same VLAN. So it's a good little a tool for this use case. Okay, so Wireshark's giving me some issues between the switch and the client. So we're gonna just look between the two switches and verify that the VLAN is or the DHCP packets are actually crossing between the two switches. And we can actually verify some of the Ethernet header ideas that I was talking about here. So I'm going to go ahead and stop this packet capture because we're going to keep getting per VLAN spanning tree frames, all that good stuff. So what I've got here, what I've got highlighted is this frame right here. You can tell it's a DHCP discover packet, which is what we would expect, right? So like I said last time, we've got the how many packets we've got on the top. We've got the header of the packet we've selected and then the byte information on the bottom. So if we look at the headers here, we can see that we've got a new little 802.1q. I wouldn't really call it a header. It's technically an insert, but Wireshark seems to treat it as a header. And we can see that we actually have our VLAN ID for this packet. It's right there on the third row. It says ID 3. So the switch is sending that packet to the other, or excuse me, sending that frame to the other switch, and it adds this little tag right there with the ID of 3. What should be happening is that the switch then says, okay, I've got a broadcast packet. I'm going to send it out all ports except the one I received it on. And then it throws that down to PC2 at the bottom. And then if you were to capture that packet, you would not see any of this 802.1q header information or insert information because, like I said, the switch strips that before it's handed to the client. So basically what we've got here is we've got two switches. We've created one VLAN that can span between the two. And then, we've expanded our broadcast domain. All right, sweet. So just for some review, we talked about how to create a VLAN, what a VLAN is, and whether or not it has some security implications. And then we talked about how to span a VLAN across two switches and what that would look like within a Wireshark header, and how you would configure that within a Cisco switch. All right, catch up with us next time for our part 3 video where we talk about spanning tree way more in depth. So I'm Austin with pdq.com, and you have a great day.